Okay, so we'll have a look through question 7, part 4 here, talking about the area and the arc length of a sector of a circle. So the circle that we have here, or the sector that we have, is about 3/4 of a circle by the looks of things. So that means the total angle inside the sector is going to be 270 degrees, because it's 360 degrees in the full circle, taking away a 90-degree chunk of that. So 270 degrees. Now, if we look in our log tables, we can get the formula for the area of a sector. And that says that the area is equal to pi r squared times the angle, theta, divided by 360. Now, just so we understand where this formula is coming from, the area of a circle is pi r squared. So if we just filled in this much, it would give us the total area of that circle, including the missing section. Theta, our angle, divided by 360 just gives us a fraction of that total area. So in this case, if we were to put in 270 over 360, that fraction would actually simplify down to 3 over 4, which means we're getting the entire area of the circle, then we're multiplying it by 3/4 to find 3/4 of that area. So we can start filling that in now to practice. So area is equal to pi times the radius squared, which is 8 meters, times 270 over 360. Now again, pi times the radius squared would give us the full area of the circle, and then this is our fraction of the circle that we're talking about. So we're only talking about 270 3/60ths, or 3/4 of the area of the full circle. Now you'll notice that we have not subbed in 3.14 or 22 over 7 for pi. That's because in the question they say give your answer in terms of pi. So that means we just leave pi by itself and we'll give the answer as 13 pi or 24 pi, just like it's an x or another variable. So if we multiply this out, pi will stay the same. Again, because we're asked to give our answer in terms of pi, so that means you don't sub anything in for pi. 8 squared will give us 64. We'll just solve this out using BIDMAS. We do brackets first, which you can't simplify, so then we've done indices. So now if we multiply 64 by our fraction, we get 48. Giving us a final answer, we generally write pi afterwards, after the regular number, just like we'd write x after a number when they're both multiplied by each other. 48 pi. Our area is usually measured in squared units, so our unit that we started off with was meters, so that means it's going to be meters also for our unit, but meters squared. And we'll have a look at the second part of this question now, where we're asked to find the length of the arc for this sector of a circle. So the formula for the length of the arc is 2 pi r, again, and times by this fraction, theta over 360. So this formula here should also look pretty familiar. It is just the circumference of a circle. So the total length of the outside of a circle and multiplied by the fraction. So in this case, it's going to be 270 divided by 360, or 3/4. So if you imagine getting the full circumference, then we're actually only going to get 3/4 of that by multiplying it by this fraction afterwards at the end. So we can fill that in. Again, we're asked for it in terms of pi, so we'll just leave pi as it is instead of trying to sub in a value. So 2 times pi times the radius, which is 8, then times by 270, our angle, over 360. So we can simplify 2 times 8 first of all. That's going to be 16 times pi, then times 270 over 360. So if we multiply 16 times 270 divided by 360, it'll give us 3 quadrats of 16 over just 12, then times pi, and our unit is going to be the same as we were given in the question, so that'll just be in meters here. If you are asked to give your question as a decimal, then all you need to do at this point, or even earlier on, you can sub in 3.14 instead of pi, or else at the end you can multiply 12 and multiply it by the pi button on your calculator, and that'll give you your answer as a decimal.